For the next few moments, we're going to focus on the use of wildcards at the Linux command prompt or Linux terminal window. Here in your textbook, we notice a table 5-1 that discusses some of the primary wildcards that you'll use. The two most commonly used wildcards are the star or asterisk and the question mark. So let's begin with those. When we think about wildcards, we're thinking about substitutions or ways of building file names or references to things that allow us to pull more than one file from a particular location. That'll make more sense as we demonstrate it. But let's first start with this notion of the asterisk and the question mark. The asterisk stands for 0 or more characters. 0 or more characters. That's very important. The 0 part is very important. The question mark stands for a single character. So if I want to reference one unknown character, I have to use one question mark. If I want to reference two unknown characters, I must use two question marks. So let's take those concepts, go back to my terminal window here, and let's look at a few examples of how we can use those with commands. First of all, I'm going to do a listing of my home directory, and notice again I've got several files in here that I've created. Let's take, for example, the star, and let's say I want to do a listing of all files that end in .txt. Let's state that again. I want to do a listing of all files that end with a .txt extension. My command is ls, and in this case, I want to see all files that end with a .txt extension. I do a star .txt. Now let's look at this just for a moment. Again, my command is ls, but in this case I'm going to use the star to allow myself to bring up a variety of different files. In this case, I do not care how many characters come before the .txt. I'm only interested in identifying those files that end with .txt regardless of the number of characters before the dot. At this point I'll hit an enter key, and notice what we get pulled up here. We get a variety of different files ending with a .txt extension. Notice again the commonality. The commonality is the .txt extension. Notice the dot is an important part of this. Looking at the file names, let's use the question marks then, for example. Let's say we wanted to pull up any file that ended in .txt but had 5 characters before the dot. ls, then I'm going to use 5 question marks. 1, 2, 3, 4, 5, .txt. Notice my list is quite different this time. At this point, I'm pulling up only files that have 5 characters, then a .txt at the end of the file name. Let's look at a few other examples using a combination of different items. Let's say I want to pull up any file that ends with a 3-character extension. Again, what these wildcards say is give me a listing of files that have a dot and then 3 characters at the end of the file name. List looked pretty similar from before, but let's change that just to see the behavior here. I'm going to take away one of the question marks. So now it's looking for any file that ends with a dot and then 2 characters. Notice my output is much different now. It does not list the .txt files because the .txt is 3 characters after the dot, whereas what we've indicated here with our 2 question marks is simply 2 characters after the dot. Not 1 character, not 3 characters, but specifically 2 characters. Now let's change that behavior slightly and use a star. Now effectively what I'm saying here is show me any file that has a dot in the middle of it. I don't care how many characters come before the dot. I also do not care how many characters come after the dot. So in this case, I see .txt files, I see .gz files, and I see a variety of file name links. Keep in mind that in Linux and in Unix, file name extensions are not always used. We've used .txt extensions here in these file names for clarity, but again, file name extensions are not necessarily required in a Unix or Linux system. Now, let's use these examples with something like a copy command. My command is copy. Let's say, for example, I want to copy all files that end in .txt to a test folder in the /tmp directory. So I'll copy star.txt to /tmp/test. In this case, no news is good news, typically in Linux or Unix. So let's do a listing of that folder to see what we've got. Well, we effectively copied all files that ended in .txt to that test directory. So the star in this case allows me to use the copy command to effectively move an entire group of files that have a common characteristic. In this case, the common characteristic is the .txt extension. It allows me to move all of those files over to the /tmp/test directory. In the same way, I can use the rm command recursively to delete all of these files. In this particular case, with the recursive option, it would delete everything anyway. So just as a matter of example, let's see what would happen if we took away our recursive option. We get no output from the command. So let's go back and look at our test directory. It's empty. Is my test directory still there? Notice my test directory is still located there in the /tmp directory. So this is a change in behavior in what we saw from our previous video dealing with the rm command. If I had left the recursive option in, it would have deleted both the test directory and everything in it. Now, let's also look at some other options here. How can we be a little more sophisticated with our use of wildcards? Going back to your textbook in Table 5-1 and 5-2, notice the use of brackets. If I use brackets and encase characters within those brackets, it will match any character that is a member of the set of characters listed inside of the brackets. So inside the bracket says match these characters. Let's go back to our terminal and see how we can use that. Let's do a listing of my home directory again to see what files we have available to us. Notice we have a file called 4file.txt and 5file.txt. Let's say I wanted to copy just those two files to the temp directory. Given that it's only two files, I could simply list both of those on a single line of command and do it that way. But for demonstration purposes, we'll use the brackets. I'll do a copy. I'll start the bracket. Then I'll list the two different characters. Then I'll say file.txt. Now, when we look at the 4.5, this looks like a 45 to us. However, to the terminal, it sees this as two different characters. The terminal will only understand typically characters 0 through 9 and usually does not make combinations of characters unless we purposefully manipulate the terminal and the brackets so that it will look for those characters. So at this point, it's going to look for 4file.txt and 5file.txt if we constructed it properly. I'll give it my destination, which is /tmp, and do a listing of the /tmp directory. And notice that file.txt and 5file.txt have been copied to the /tmp directory. Similarly, if I do a listing of my home directory again, we see a variety of lowercase and uppercase file names. We see lowercase and uppercase A and B's, lowercase and uppercase C and D's as well. We can use the same brackets to select files that we want to copy from that range also. So we'll do a copy. And let's say I want to get the uppercase and the lowercase A files and copy those to the temp directory. In this case, it's going to look for any file that starts with a capital A or a lowercase a, then has faile.txt after it, and copy them to the temp directory. I'd list my /tmp directory again, and I can see where the lowercase a file.txt and the uppercase a file.txt have been copied to the /tmp directory again. Now, using wildcards, if I wanted to delete all of the .txt files from the /tmp directory, how might I do that? We know that to delete a file, we use the rm command. We know that we do not care what the file starts with, 0 or more characters, so we can use a star, but we do want them to end in .txt. So we've said remove star.txt. But what are we missing at this point? If I enter the command as I have it typed in, where will it remove those files from? Correct, it will remove them from my present working directory, which is my home directory. But what I'm interested in doing is removing them from the /tmp directory. It's always important to make sure that you're removing, deleting, or copying files from and to the correct source and destination. Now, if I list my /tmp directory, I should see that all of the .txt files are missing now. Interestingly enough, we also have a file in here called Unity Support Test.1. What if we wanted to delete that? How could we delete that file using a combination of wildcards? In this particular case, what does it have in common? It has a single character extension, and it has a .1 at the end. So we could do this in a variety of ways in this particular situation. I could do rm star.1. This will delete any file that ends with a .1. Another way to do it that would work in this case would be to remove any file that ends in a dot and then a single character. It would not matter what the single character was, a .1, a .a, a .z, a .9. As long as it ended in just a dot and a single character, it would remove that file. Typically, you want to be as specific as you can so that you don't delete unwanted files. Again, what's going to happen at this point? It would delete these files from my home directory. So I want to make sure that I put in the correct location that I want to delete files from. Hit the Enter key, and it tells me this file is write protected. Do you want to delete it? I'll select yes, and it tells me it cannot remove it. Why is this? Notice the description of the file here. It says write protected regular file. That means a special characteristic has been turned on about this file that prevents it from being deleted unless I turn off that characteristic. You may run into files with this particular setting put in place. If that setting is put in place, you need to question seriously about whether or not that file needs to be deleted. That characteristic, that write protection, has been turned on for a reason. So we want to be very careful about disabling that. In our next video, we'll continue our discussion of wildcards as well as the link command.